All right, I think we've about got everybody loaded in. So let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's see, who are we missing? Got my 2 Zoes, Claire, Evelyn, Mark. Grant and Micah, and Jonas and Mark. Who am I missing? Katie and Kinsley. Zoe's. Oh, Sadie. Yep, Sadie. Waiting on Miss Sadie. Okay, so we'll go ahead and get ready to get started. We have been working with our systems of equations. We have learned that a system of equation is when I have a couple, here she comes, a couple of equations that both have x and y values. When I'm working on solving systems of equations, I know that I have to figure out a way to eliminate or to get rid of one of my variables to be able to solve for the other one, then plug that value in and solve, okay? So basically it's figuring out different ways that I can solve for each of my 2 variables in the equations. And so we started out first of all by saying, hey, if I can solve each equation for the value of y, if I can solve each of them for the variable y, then I can substitute the rest of my problem. So if I have it in slope-intercept form, y equals mx plus b, and I have this one as y equals mx plus b, and this one as y equals mx plus b, then I can take the mx plus b part of this one and the mx plus b part of this one, and I can set them equal to each other. Okay, so that was the first thing that we did. And then the next thing that we did was we looked at being able to add polynomials. And so we have looked at if we add opposite terms. So like if I have 3x and negative 3x and I add those together, that equals 0. So when that one equals 0, I can end up solving for the other variable. I can eliminate one by adding and then solve and be able to solve for the other. So let me go ahead and pull up my notes and share my screen and all that good stuff. And let's see if we have any questions that we need to go over before we get started. Solving systems of equations.
Yeah, I remember I wrote a star here because I wanted you to go back over the solving literal systems of subtraction.
Okay, we haven't gotten there yet.
Oh, I was saying, well, that was lesson 54.
Yeah, we haven't. So we started that, but we didn't have work on it. We're going to start by reviewing that, and then so we will. Yeah,
we'll did the work for that, and I didn't understand it, and I was like, oh, that's because class ended early.
Okay, so let's go ahead and take a look at what we did have for homework. So for homework, let me pull this up real quick. Let me share my screen real quick, and then we'll. There we go. Okay, so where we left off the other day is we had gone through, hang on just a second, let me fix my screen real quick so I can make sure if anybody gets kicked out, I can see you trying to get back in. Whoop, we don't want to do that. We do want that. Okay. Alrighty, so quick review. We started out, we did our review of adding and subtracting polynomials. And then for our homework, I went ahead and combined it all right here. So we had lesson 51, page 116, activities 3. So let's see. Hold on a second. Let me look at this because that doesn't correspond. So page 115. Activities 2. That was our first part of homework, right? Page 115, activities 2 in the workbook, or did we finish that in class?
I thought our first homework was activities 2 and 3, page 114.
Okay, I just didn't go far enough, my bad. Okay, here we go. We had to complete activities 2 and finish activities 3. So let me flip back to that. Did I have that? I was thinking. Okay, I thought we had checked that one because I had shared that one on the screen the other day. Let me pull that up real quick and make sure everybody's gotten a chance to look at that. Yeah, that was page 114, activities 2 and 3. So we had checked those. Are you saying something, Zoe, Wally?
I said, I think we checked that Monday.
Yeah, we checked that on Monday, was page 114. Okay, so we checked page 114 on Monday, and then we go back to, so we have checked that one. All right, so page 115, activities 2 in the workbook. What I'm going to do is I'm going to take a picture of this one and we'll put it on the screen and look at that one. You can check your work. And actually, it may just be easier. Hold on. Go back to that page in the book. Do I not have these pages in here? I think it might have gotten. Hang on. Where have my pages gone? All right, hold on just a second. Let me pull this together real quick because I don't know where those pages went. let's see. What I'll do is I'll put page 115 up and you can be checking that while I get the other ones together. So let me get that transferred over real quick. This is page 115. All right, so page 115, go ahead and look at those. Go ahead and check your work. Actually, let's see if it'll be, if I can make it bigger if I turn my screen this way. Okay, be checking your work while I get the other pages loaded. Go ahead and get them all in there, and then that way I thought they were all there, but they are not. So we'll just do it again. I'm going to go ahead and do every page just in case. Almost there. All right. Let's send this over real quick. All right, so any questions on these that we just checked, page 115? Any of the questions on these? Everybody good with them? Everybody's checked your homework? Okay. Let's go ahead and get back. And all right, so we checked that. Now let's keep on going. And we started working with our addition and subtraction. And so our next thing was page 116, activities 3. So let's look at page 116, activities 3. So let me pull that up real quick and we'll look at those. I'll go ahead and write those on. Whoop, wrong page, wrong thing. Okay, so we're going to page 116, activities 3. So what I will do is we'll pull that up. Don't tell me I didn't get that picture. Good grief. I'll tell you what we're going to do. Let me just get a piece of paper real quick. This will be page 116. Okay, activities 2. I'm going to number them across the top, 1, 2, 3, and then 4, 5, 6. Okay, that's what we're going to do. So turn to page 116 in your book or on your paper that you did. And so activities 2, we started out with negative 2x plus y minus 1 equals 0, and 3x plus y plus 24 equals 0. So on this one, let's see, this is lesson 52. Okay, so on number 1, your answer for x should be negative 5. Y is negative 9. Any questions on that one? All right, number 2, going side to side. So the one next to it, negative 2x minus y plus 12 equals 0, and 2x plus 2y minus 6 equals 0. You find that x is equal to 9, and y is equal to -6. Any questions on number 2? All right, keep going. 3 next to it. We start with x minus y minus 2 equals 0 and -2x plus y plus 9 equals 0. X is 7 and y is 5. Any questions on that one? All right, and remember, I'm going to need to see your work on these to see how you solve them. So on number 4, we're in the second row, first problem on the second row. X minus y plus 10 equals 0, and -3x minus y minus 2 equals 0. X is -3, y is 7. Any questions on that one? Number 5, -2x plus y minus 9 equals 0, and x plus y plus 6 equals 0. X is -5, and y is -1. Any questions on that one? And then finally, number 6, -2x minus y plus 10 equals 0, and 2x plus 2y minus 6 equals 0. X is 7, y is -4. Any questions on page 116? All righty. So then our next one was page 118. So let me go back. So we got that one checked. So now we have page 118, activities 3, solve by elimination, adding. So page 118. Is right here. All right, so the first one, if x is 4, y is 3. The second one, if x is -4, y is -3. And of course, this one cut off. So our answer here is going to be -3, -5. Okay, so those are our 3 answers for activities 3, page 118. Any questions on that? All righty, so that was all of our homework to check. So now let's flip back to our note sheet. And let's review what we had started on elimination by subtraction. So this is going to go along with lesson 54. Elimination using subtraction. All right, so remember, when we are using elimination by subtraction, anytime that we've dealt with subtracting multiple terms, we found that it was most helpful to go ahead and change from subtraction to addition, and then make sure that we change the signs of each of the following terms. So in this situation, that's what I said, the key to know when we're going to subtract is when we see the same terms in an equation, in the 2 equations. So here we saw that we had both positive y or plus y and plus y in each equation. Now, of course, we learned previously that we could go ahead and solve each of these by setting them equal to y and substituting or doing that. But I wanted to show you how you could also do the same thing using subtraction here. So we saw that these 2 are like terms. I have plus y and plus y. So I know that if I subtract y minus y, that ends up eliminating that and making it 0. So what we've done here is, in this particular example, we started out by writing a subtraction problem, okay? So let me erase this real quick. Let me erase my yellows. Whoop. And we rewrite them real quick. So that was 3. So we said that I can look at this. Oh, forgot that guy. Okay. So originally I would start out by having my first equation, -3x plus y equals -4, or or I wrote it in standard form first. And then I could subtract my second equation, minus 3x plus y equals 2. But it's going to be much better if we change to adding the opposite, because it's very easy to make a mistake here. If I were to say -3 minus 3x, I might look at that and say that is 0. So what I want to do is I want to make sure to change to adding the opposite. So I want to change subtraction to addition, but I have to change the term of each term, and so I have to change the sign of the term. So now my 3x in parentheses becomes -3x, plus y becomes minus y, and +2 becomes -2. So then I have -3x plus a -3x is -6x. Plus y plus a -y cancels out. I've changed it now to adding the opposites. So those cancel. And then -4 plus a -2 is -6. So we found that x is equal to 1. Once I see that x is equal to 1, I plug it in. And I'm able to solve and find that y is equal to -1. Y'all can see I have a friend trying to pop up over my side. She's getting upset because I won't pet her. I'm trying to do math right now. She digs at my arm constantly for me to pet her. Stop. Okay, so we found that x is 1, y is -1 with subtraction. So we're going to keep practicing with that today on how to change to adding the opposite. Okay. So on page 119, we're going to look at that classwork there. So first of all, real quick, let's look at our rules. Rewrite in standard form is the first. Change from subtraction to addition by adding the opposite is step 2. Add vertically and eliminate one variable, solve for the other, substitute, and write our answer as an ordered pair. So let's go ahead and look at classwork. Remember, what is step 1? The first thing I have to do is to write each equation in standard form. So that's what I'm going to do first. I'm going to go ahead and rewrite this in standard form. So remember, when I'm doing standard form, it's ax plus by equals c. So the main thing here that needs to move is that -5. I'm going to move it by adding. So that means now my equation is 3x minus y equals 5. Same thing for my next one. It's my c term that needs to move. My term is +4, so that means I need to subtract 4 from each side. So now I have 3x minus 2y is equal to -4. Now at this step, I can see that I've got 3x and 3x in each of my problems. So that's when I have identified that I've got the same terms. So if I have 3x minus y equals 5 minus 3x minus 2y equals -4. If I subtract 3x minus 3x, that gives me 0. But I have to be super careful, because just because I have subtracted those two terms, the following terms have to be adjusted because of my subtraction. So this is where I want to go ahead and change to adding the opposite. So what I'm going to do is I'm going to go ahead and change. I want to change this to addition. This becomes a negative, this becomes a positive, and this becomes a positive. So I'm going to rewrite my equation where I've got 3x minus y equals 5 plus -3x plus 2y equals +4. I have changed to adding the opposite. My subtraction sign becomes an addition sign, and I've changed every sign of the second term, or my second polynomial. So now I've got 3x plus a -3x. Again, I've been able to see where these two are going to cancel each other out. 3x plus a negative 3x equals 0. So that just goes away for now. And I've got negative y plus a positive 2y. So negative y plus a positive 2y is a positive y equals 5 plus a positive 4 is 9. So I've been able to solve and say y equals 9. So if y equals 9, I can plug that into, I'm just going to start with that first little equation up here, 3x minus y equals 5. And now I'm going to plug in 3x minus, I'm going to put my 9 in parentheses, equals 5. So 3x minus 9 equals 5. So I'm going to add 9 to each side. And 3x equals 14. Divide by 3, divide by 3. X equals 14 over 3. Let me look at that and make sure. Sometimes they'll throw in these crazy problems. And I have made a mistake. What did I do wrong? Let me make sure, first of all. Where did these problems come from? Because these are not the same problems. I must have typed the wrong problem. Where did those even come from? Oh, no, 3x minus y minus 5. That's the, okay, y'all. I'm losing my mind. So evidently what I did is somehow, nobody told me I was working the wrong problems. Y'all gotta speak up and tell me. So evidently I have lost my mind and where are my classwork problems? For lesson 54. Good night. All right, let me shift back because these aren't even the same problems on lesson 54 for classwork. Somehow I've got a mixture between something and then I've got activities 2, but I even typed that one wrong. So this has been one of those weeks where I just have, okay. Let's start from scratch. Lesson 54, page 119, classwork. We start with negative 3x plus y minus 5 equals 0, and 4x plus y plus 2 equals 0. Okay.
Should we write in the
Yes.
book?
Huh?
We write this in the book?
Yes, you can write this in the book. Yeah, this is on page 119. Write it in the book. This is classwork. Negative 3x plus y minus 5 equals 0, and 4x plus y plus 2 equals 0. Immediately, I can look and see that I've got these like terms here, so I can see that if I subtract, they would go away. Okay, they would cancel out. But remember, the first thing I need to do is standard form. Okay, so when I go to standard form, I need to add 5 on this one to each side. So I end up with negative 3x plus y equals 5. And here I'm going to subtract 2 from each side. So 4x plus y equals negative 2. Again, I can still see that those are the terms that I'm going to eliminate because right now they're exactly the same. So if I have negative 3x plus y equals 5 minus 4x plus y equals negative 2, This is where I want to go ahead and change to adding the opposite. So I'm going to change my subtraction to addition. Positive 4x becomes a negative 4x. Plus y becomes minus y. Negative 2 becomes positive 2. So I want to go ahead and rewrite that. And I have negative 3x plus y equals 5 plus negative 4x plus y equals negative 2. So now I have negative 3x plus a negative 4x is negative 7x. I forgot to rewrite that as a negative y. Y plus a negative y, those cancel each other out. And 5 plus a negative 2 is 3. I didn't rewrite my problems right. I'm sorry, guys.
Isn't 2 positive?
Yes, it is. So 5 plus 2 is 7. That's why I was going, okay, that's not going to work. That's still going to be a fraction. So I've done something wrong. I changed them over here, but when I translated it over, I did not rewrite them correctly. So negative 7x divided by negative 7 and 7 divided by negative 7. I'm dividing both sides by negative 7. So x is equal to negative 1. So now I'm going to take that negative 1 solution for x, plug it in to one of my equations. I'll go ahead and start with negative 3x plus y equals 5. So I'm going to plug in my negative 1 for x plus y equals 5. Negative 3 times negative 1 is a positive 3 plus y equals 5. Subtract 3 from each side, so y is equal to 2. So my ordered pair solution will be negative 1, positive 2. Phew, that was a long way to get there. Hopefully the next one I'll do much better. Now at least I'm on the right page with the right problems. Okay, so the next one in classwork, I have x minus y plus 2 equals 0, and 2x minus y plus 5 equals 0. So I know the first thing I've got to do is write them in standard form. So that means over here I need to subtract 2 from each side, and on this one I have to subtract 5 from each side. So I have x minus y equals negative 2, and 2x minus y equals negative 5. I can see here I've got negative y, common terms for both equations. So I know I'm going to subtract. So I'm going to have x minus y equals negative 2 minus 2x minus y equals negative 5. I want to change this to adding the opposite. So I keep my first equation, x minus y equals negative 2, but now I'm going to add the opposite of every term. So now my positive 2x becomes negative 2x, my negative y becomes positive y, and my negative 5 becomes a positive 5. Now I add them up, and x plus a negative 2x is negative x. My negative y plus a positive y cancels out, so I don't even have to write a 0 or anything. So I put my equal sign, and negative 2 plus a positive 5 is going to be 3. So I know that if negative x equals 3, then a positive x equals a negative 3. So I found that x is equal to negative 3. So now I'm going to plug it in. I'm going to plug it into my first equation where I had x minus y equals negative 2. I'm going to plug in negative 3 minus y equals -2. So now I'm going to add 3 to each side, and negative y is equal to 1. So a positive y is equal to -1. So my ordered pair solution is -3, -1. Any questions on that one? Step 1, standard form. Step 2, make a subtraction problem, but then I'm going to have to change it to adding the opposite. So once I've got it set up to adding the opposite, I'm going to go ahead and do that and solve for the one variable that's left over. Then I go plug in that variable to solve for the other variable. And then the last step, I write my answer as an ordered pair. All right, the last one in activities, classwork 1. I start out with 3x plus y minus 5 equals 0. And 3x minus 2y minus 8 equals 0. So the first thing I've got to do is I've got to write them in standard form. So that means I have to add 5 to my first equation and add 8 to the second equation. So 3x plus y equals 5. And 3x minus 2y equals 8. I'm able to see that my like terms are the 3x's. So I can see that those are going to be the ones that I'm actually eliminating. So 3x plus y equals 5 minus 3x minus 2y equals 8. I want to change to adding the opposite. So I keep 3x plus y equals 5. Now I'm going to put a plus sign and take the opposite of every term. So 3x becomes -3x, minus 2y becomes plus 2y, positive 8 becomes -8. And I can add them up now. 3x plus a -3x cancels out. And y plus 2y is 3y equals 5 plus a -8 is -3. So now to solve for y, I'm going to divide by 3 on each side, and y equals -1. So now I have found that y is equal to -1. So I need to plug that value in to one of my previous equations to solve for x. I'm going to use the 3x plus y equals 5. I'm going to plug in that -1. So 3x plus -1 equals 5. So I know if I have plus a negative, that's the same as 3x minus 1 equals 5. Add 1 to each side. 3x equals 6. Divide by 3, divide by 3. And x is equal to 2. So my ordered pair solution, x is 2, y is -1. Any questions on that? Remember, we're doing the same process as we do with addition, except we have one extra step where we have to change from subtraction to adding the opposite. When I add the opposite, I not only change my minus sign to a plus sign, but every single term in my second polynomial has to have opposite signs, okay? So let's go ahead and look at activities 2. I'm going to flip back to my notes and I'm going to rewrite that one note that evidently I just totally typed it wrong. So we're going to fix that real quick.
Are we going to write this in the book or the packet?
You can write this in the packet, but we're going to fix it first. Make sure we've got the right problem written down. Okay. So we're starting in that second column where it says page 19, activities 2, eliminate by subtracting. And so what is wrong with this problem? Let's fix it. So the first problem is, the first equation is 3x minus y minus 5 equals 0. That one is correct. But underneath it, I need to fix this. It should be 3x minus 2y, and this should be minus 7. equals 0. So that plus 4 is where I messed up. It should be minus 7. Okay, so just go ahead and scratch that out and put minus 7. The first thing we've got to do, though, is standard form. So in my top equation, I know to go to standard form, I'm going to have to add 5 to each side. And now in my second one, I'm going to need to add 7 to each side. So now we're going to rewrite those in standard form. So I have 3x minus y equals 5 and 3x minus 2y equals 7. Here I can see that my 3x terms are exactly the same, so I know those are going to be the ones that I'm able to eliminate. So I'm going to go ahead and rewrite this as 3x minus y equals 5 minus 3x minus 2y equals 7. I want to change by adding the opposite. So I keep 3x minus y equals 5. My first stays the same. Now I'm going to change from subtraction to addition, but now I have to take the opposite term of everything in parentheses. So 3x becomes negative 3x, negative 2y becomes positive 2y, and 7 becomes negative 7. And now I can add them up. 3x plus a negative 3x ends up canceling out. Okay, that is 0. So now I have negative y plus a positive 2y. Negative y plus a positive 2y is going to give me a positive y equals 5 plus a negative 7 is negative 2. So y equals negative 2. I'm going to take that, plug it in to my original equation, which was that first one, 3x minus y equals 5. Now I'm plugging in a negative 2. So I'm going to have 3x minus a negative 2 equals 5. This is why I like to write everything in parentheses so I don't make a mistake with those signs. We can see now that I've got minus a negative 2. So remember how we said if I have minus a negative 2, that's the same as plus. So I can change that to a positive. So now I have 3x plus 2 equals 5. Now I've got to start solving for x. The first thing I need to do is take away 2 from each side. And 3x is equal to 5 minus 2 is 3. So now I have 3x equals 3. So that means I need to divide each side by 3. And so x is equal to 1. So my ordered pair solution, x is 1, y is negative 2. So there is my solution for activities 2, the first one. Any questions on that? Any questions on how we did any of these? First thing we do, standard form. Second thing we do is we write our subtraction problem and change it to adding the opposite. Then we go ahead and solve for one variable, plug in that solution, solve for the second variable, write our solution as an ordered pair. I want you to go ahead and work the second one in activities 2, and then we're going to check it. So right now you are working on 4x minus y plus 2 equals 0 and 2x minus y plus 4 equals 0. Chad?
No, it's I think it's break time.
Is it? Okay. So yeah, let's go ahead and take a 5-minute break and then we'll come back and work on this problem. Thank you. All righty, we'll get ready to come back. Give me a thumbs up so I know you're back if your screen is off. Or you can turn your screen on either way, just so I can see that you're there. All righty. Are my King sisters back? Did I have Betsy and Sarah? Betsy and Sarah, are y'all back? I think we have lost Betsy and Sarah. Betsy and Sarah, are y'all back?
Yes.
Okay, thank you. I just wanted to make sure everybody's back. I don't want to start without anybody. Okay, so now what we're going to do is we are going to look at the second one in activities 2. I want you to go ahead and work on that on your own. Once you are done, I want you to give me a thumbs up and we'll go over it. I hear you, Jonas. Thank you, Katie. Good job, Claire. Remember, if you have to, look back at your steps. It's just steps in a process. What's the first thing you do? What's the second thing you do? Just keep on going. All right, we're going to get started on this. So remember, step 1 is to go ahead and put it in standard form. So I would need to subtract 2 from each side, subtract 4 from each side. So to write this in standard form, I have 4x minus y equals -2. 2x minus y equals -4. I can see here that in both of my equations, I have minus y or negative y. So I know I can set up 4x minus y equals -2 minus 2x minus y equals -4. I want to change from subtraction to adding the opposite. Keep my first equation as 4x minus y equals -2. My second one, I need to change to addition, but that means I have to change the sign of each term inside parentheses. So 2x becomes -2x. Negative y becomes +y. -4 becomes +4. Now I'm going to add them up. 4x plus a negative 2x is 2x. My negative y plus y cancels out, equals negative 2 plus 4. Negative 2 plus 4 is going to give me a positive 2. So now I have 2x equals 2, divide by 2, divide by 2, and x is equal to 1. If x is 1, I'm going to plug it in to 4x minus y equals negative 2. So I have 4 times 1 minus y equals negative 2. 4 times 1 is 4, minus y equals negative 2. So I'm going to subtract 4 and subtract 4. So negative y equals negative 6. Therefore, a positive y equals a positive 6. So my ordered pair solution is 1, 6. Questions on that? Did you do okay? Did you solve and get the right x and y numbers? Now, one of the things to always make sure of that even if you solved and you got the value of y first, just make sure in your ordered pair, it's always x, then y. So make sure when you're writing your answers in your ordered pair, you get them in the right order. All right, go ahead and do the last one in activities 2. Go ahead and work on that last one. All righty, we'll get ready to start working on this one. Again, step 1, standard form. So that means I need to move my C value. So I'm going to add 7 to each side on my first equation, add 1 to each side on my second equation. So then I'm going to have x minus 2y equals 7, 3x minus 2y equals 1. I can see that my minus 2y's are exactly the same, so I need to go ahead. I can see that if I subtract those, I can change to adding the opposite. So x minus 2y equals 7 plus 3x becomes negative 3x, minus 2y becomes plus 2y, and 1 becomes negative 1. Add them up. X plus a negative 3x is negative 2x. 2y plus 2y cancels out, so my y values are gone, equals 7 plus a negative 1 is positive 6. Divide each side by negative 2, so I find that x is negative, whoops, I forgot my negative, negative 3. So x is negative 3. I'm going to plug it back in. I've got x minus 2y equals 7. So I'm going to put my negative 3 in for x minus 2y equals 7. So that means I'm going to add 3 to each side. and I get negative 2y is equal to 10. Divide by negative 2, divide by negative 2, so y is equal to negative 5. My ordered pair solution will be negative 3, negative 5. Any questions on that? Any questions? All right, so now what I want to do is let's go ahead and on what you can do is if you want to, you can flip over on the back of the sheet of paper if you want to, or you can get out a brand new sheet of notebook paper. But I want to kind of process through what we've done so far. So when we're looking at a system of equations, there's going to be several things that I need to be able to look at and assess to decide how am I going to solve this. We found out that the first way we could do is if I can see that I can solve for y, then I could just go ahead and use slope-intercept form and set them equal to each other. Then I looked and said, hey, if I see that I've got opposite terms, I can add to cancel those out. We just worked on if I have the same terms, I can use subtraction. Okay, so let's go ahead and make a couple of notes here about this. And so how to determine which method to use when solving systems of equations. Now, wherever you put this, I need it to be in a safe place because we're going to be kind of adding to it as we keep going. Okay, so we're just going to go ahead and start out with the first few things, and then with our additional lessons, we'll keep adding to it. So the first thing, if you can solve each equation for y, and I'm going to put in parentheses slope, forgot my E, intercept form. So if I'm able to solve for slope-intercept form, then use, we called that, see, our book called it setting the equations equal to, but I think we called it substitution. Then use substitution, and I'll put in parentheses, setting equal to each other. So I'll put as an example, if I have y equals mx plus b and y equals mx plus b, then I can go to mx plus b equals mx plus b. I can set them equal to each other. I solve each of them for y, and then I set them equal to each other, or I substitute mx plus b for y and set them equal to each other. Okay? So the first thing I do is I look and say, hey, can I solve for y? If so, this is the method I'm going to use. Okay, but that's only if y is all by itself in both equations. So I'm going to put a note here. Y must be by itself in both equations. Okay. Now let's say that you look at an equation and you go, nope, I can't solve for y in both of them. Maybe I could for one of them, but maybe the other one is 2y and I couldn't solve for y. So then the second thing I'm going to do is I'm going to look to see if you have two terms that are opposites of each other. look to see if you have two terms that are opposites of each other. And I'm going to put an example, 3x and negative 3x, 2y and negative 2y. Okay, those are my examples. Okay, do I have like but they've got to be opposite. So I know one has to be positive, one has to be negative, but they've got the same coefficient and the same variable. So if I see that I have two terms that are opposites, I'm going to solve by addition. If I have opposites, two terms that are opposites, I solve by addition. Now, number 3. Let's say I don't have two terms that are opposites. So I'm going to look to see if you have two terms that are alike. My examples would be 3x and 3x, or 2y and 2y. Are they exactly the same? If so, solve by subtraction, what we have just finished working on. So two terms that are alike, solving by subtraction. So basically what we've just said is if I can solve each of them for y, I'm going to set them equal to each other. I'm going to use the substitution method. If I have two terms that are opposites, I'm going to solve by addition. If I have two terms that are exactly the same, I'm going to solve by subtraction. Okay, so far that is where we've gotten. But now let's look at this example. What if I have 3x plus 2y minus 4 equals 0, and I have x plus 3y plus 1 equals 0? Okay, I'm going to look at this and say, okay, my first test, can I solve each of these for y? No, I've got 2y in the first one. I've got 3y in the second one. I cannot solve for y. So I'm going to go to test number 2. Do I have terms that are opposites of each other? No, I've got a 3x and an x. Those aren't opposites. I have 2y and 3y. Those are not opposites. So then I go to my third thing. Do I have two terms that are exactly alike? So then could I subtract? 3x and x, not exactly alike. 2y and 3y, not exactly alike. Okay, so I cannot use any of the three processes that we have previously learned. So now what I've got to do is I've got to look and see what could I do to either one equation or both equations to be able to make like terms or opposite terms so I could add or subtract. So typically, since with subtraction, I end up changing it to addition, I want to look at what could I do to this equation or to both equations to make it to where I could add opposite terms and eliminate one of them. And this is where we start with lesson number 55 on page 121 using multiplication. So what we're going to do is go ahead and turn to lesson 55 on page 121. Lesson 55 on page 121. And it says sometimes systems of linear equations cannot be easily solved by using any of the methods that you have previously learned. When this happens, one equation can be rewritten by multiplying each term of the equation by the same number to match one pair of variables. In rare instances, both equations will need to be rewritten. So basically what I'm doing is I'm looking at this equation here, and I'm saying, is there anything that I could multiply one equation or the other by to make like terms? So let's start with 3x and x. If I wanted to make these opposite terms, okay, in this one I have 3x, and this one I have x. What could I do to this x to make it the opposite of 3x? What could I do to x to make it the opposite of 3x?
Subtract 3x from it.
Well, I couldn't just subtract 3x from it. What I would want to do is I would multiply by a -3. Because remember, I need it to be 3x together. So I'm going to use multiplication. So x times -3 is -3x. So notice now I have 3x and I would have -3x. But I could not just multiply my first term by -3x. I have to multiply every single term. Okay? So what we want to do is we want to start out by rewriting in standard form. So that's going to be step number 1. Go ahead and number that in your book. Step 1 is to rewrite in standard form. So we can see where they started. 3x plus 2y minus 4 equals 0 becomes 3x plus 2y equals 4. And x plus 3y plus 1 equals 0 becomes x plus 3y equals -1. Now, what I want to do is I'm trying to make these terms alike using multiplication. So I am going to multiply my second equation by a -3. So that means I have to distribute that -3 to each term. Okay, so now I have -3x minus 9y equals +3. Is everybody good with how I did that? I looked at 3x and said, what can I multiply x by to make it an opposite term? Because then I can just add and eliminate them. So now we can see where we kept our first equation, 3x plus 2y equals 4. We have multiplied every term by -3. Well, and actually, we're going to do this a little bit different than what the book has. So what we're going to do is we've kept our 3x plus 2y equals 4. And we're going to now add -3x minus 9y equals 3. We're going to take that equation and bring it down. So now 3x plus a -3x cancels out. 2y minus 9y is -7y. And 4 plus 3 is 7. Divide by -7, divide by -7. So y is equal to -1. All they did here is I'm doing, so basically they've got it here as subtraction, and we're just adding the opposite. So 3x plus 2y equals 4 plus -3x minus 9y equals 3. So all I did was change it to adding the opposite. So I still end up with y is -1. Now I'm going to plug in. I've got 3x plus 2y equals 4. I'm going to plug in that -1. Whoop, sorry, it's for y, not x. 3x plus 2 times -1 equals 4. 3x plus 2 equals 4. Subtract 2, subtract 2. 3x equals, what did I do? Why is oh, that's supposed to have, this is a plus and that's a negative, so that should be a negative. Negative. So now we're going to add. So 3x equals 6. Divide by 3, and x equals 2. So now we can see our ordered pair solution is 2, -1. Okay, so after we've gone through those tests, we look at it and say, hey, would I need to multiply everything or multiply something to be able to have like terms? And then lesson 56 is division. What if I needed to divide by something? We're not going to do that just yet, but just know that's where we're going. Sometimes I may either have to multiply one of my equations to make a like term or to make an opposite term, or I might need to divide to make my equations with a like term or an opposite term. Okay, so let's go back to the classwork on lesson 55, page 121. You're going to write this in your book. So remember, I'm looking at my equation. My first step, can I set them both equal to y? And when I look at that, no, I cannot. Because I've got y in one and I've got 3y in the other. So I cannot set both of them equal to y. So I look to see what about, do I have like terms? I don't have like terms. Do I have opposite terms? Nope, don't have opposite terms. Now remember, I do have a -5 and a -5, but I'm not trying to cancel those. That doesn't help me any. I need to get rid of a variable. I'm either needing to get rid of x or I'm needing to get rid of y, okay? So just because I have -5 and -5, don't let that hang you up. Getting rid of those is not going to be helpful. All right, so now I either need to look to see what could I do to make these opposites, or what could I do to make these opposites? I can choose whichever way I want to go. I'm still going to get the same answer. Typically, I'm going to start with x, but just because it's the first one. But know that if you wanted to make your y's opposite terms, you could choose y too. It does not matter if you're choosing x or y. You've just got to pick one to be able to eliminate. So what I want to do is I want to be able to make x into -2x. So I'm going to multiply. Well, let's go ahead and write everything in standard form. So let's go ahead and do that first.
Why are you multiplying by negatives instead of positives?
So if we multiplied by a positive and then we subtract, we're still going to have to change it to adding the opposite. So by multiplying by a negative, that saves me that step later from changing from subtraction to addition by adding the opposite. You could multiply by the regular number and then subtract, but then subtract by adding the opposite. So it just depends. I just like to go ahead and make them opposites because then I can just follow the rules of addition. I don't have to go from subtraction to addition. So, but the first thing I need to do is standard form. So I'm going to add 5 to each side here, add 5 to each side here. So 2x plus y equals 5, and x plus 3y equals 5. So again, I want to make opposite terms. So I'm going to multiply my second equation by -2. Multiply by -2. So that means I've got to distribute to each term. So now I've got 2x plus y equals 5 plus -2x minus 6y equals -10 or equals -10. So by multiplying by a -2, I've made 2x and -2x opposite terms. That way I can go ahead and cancel them out. So I'm going to start by canceling those. Now I have y plus a -6y. So that's going to give me -5y equals, and 5 plus a -10 is -5. Divide by -5, divide by -5, y equals 1. So now if y equals 1, I can plug that into 2x plus y equals 5. So I'm going to plug in 2x plus 1 equals 5. I'm going to subtract 1 from each side. 2x is equal to 4. Divide by 2. Divide by 2. So x is equal to 2. So my ordered pair solution will be 2, 1. Now, Zoe, like you were asking about why did I multiply by -2? Let's look and see if I would have just multiplied that by 2 and then I would end up having 2x plus y equals 5 and 2x plus 6y equals 10. But that means I would have to subtract them. So then I would have to change to adding the opposite, which is basically what that is. So by multiplying by a negative to begin with, I eliminate that step. Okay, so it just shortens my work. That's all. All right, let's look at the next one. 3x plus 2y minus 1 is equal to 0, and 2x plus 3y minus 4 equals 0. Let's go ahead and put them in standard form first. So I need to add 1 to this side, add 1 to this side, add 4 to this one, and add 4 to this side. So I have 3x plus 2y equals 1, and 2x plus 3y equals 4. Now, I look at them and I go through my list. Can I set them each to y equal to y? Nope, because I have 2y in one and I have 3y in the other. So I do not have y's by themselves. Second thing, do I look and do I have opposite terms? Nope, I have 3x and 2x. I have 2y and 3y. Those are not opposites of each other. I don't have like terms either. I've got 3x and 2x. Those are not like terms. I have 2y and 3y. Those are not like terms. So now what I'm going to do is I'm going to look at and say, okay, what could I multiply by to make opposite terms? Was there anything I can multiply 3 by to get to 2? There's nothing I can multiply 2 by to get to 3 either. So in this situation, I have to multiply both equations by a number to make my opposite terms. So I'm working with 3 and 2. What's 3 times 2? That's going to be 6, right? So in my first equation, if I want to make 3x and 2x opposite terms, I can multiply my first equation by 2, and that's going to give me 6x. And I'm going to multiply my second equation by -3 to give me -6x. Okay? So my whole goal is I've got to make opposite terms. So if I multiply my first one by 2, but remember I have to multiply each term and multiply my second one by -3. So let's see how that changes things. So now I have 2 times 3x is 6x. 2 times positive 2y or plus 2y is going to be plus 4y. And 2 times 1 is 2. So my first equation has become 6x plus 4y equals 2. My second equation, I'm multiplying by -3. -3 times 2x is going to be -6x. Negative 3 times plus 3y will give me negative 9y equals negative 3 times 4 is negative 12. So now that I see I have a positive 6x and a negative 6x, I have opposite terms. So I know that I can add these two equations together. Any questions on how we've gotten there so far? I just looked and said, hey, I can't multiply just one equation, so I'm going to have to multiply both equations. Now, realistically, I could have multiplied my first equation by 2 and my second by negative 3. I could multiply my first equation by negative 2 and my second by positive 3. I could have multiplied my first equation by 4 and the second one by 6 and made 12s. What I want to do is I want to keep my numbers as small as possible, but realistically, I could pick any numbers, positive or negatives, to multiply by as long as I'm making an opposite term to cancel. All right, so now 6x plus a negative 6x cancels. And I have 4y plus a negative 9y is going to be negative 5y equals 2 plus a negative 12 is negative 10. Divide by negative 5, divide by negative 5. Y is equal to 2. So now I go back and I can plug in 2 to any of my previous equations that I've got. So again, I could even start with this 3x plus 2y equals 1. So 3x plus 2y equals 1. So I have 3x plus 2, whoops, this 2 is part of my equation. I'm going to plug in 2 for y equals 1. So I've got 3x plus 4 equals 1, minus 4, minus 4. 3x is equal to negative 3, divide by 3, divide by 3, and x is equal to negative 1. So my ordered pair solution is negative 1, 2. So for your homework, we are going to be working on activities 2, page 122. So what I'm going to do, since I've already got that worked out, let me go ahead and give a new sheet of paper. And let's look at each of these and let's talk through what you're going to be able to do. So this is going to be on page 122, activities 2. And the directions say to solve each system of equations by multiplication. So notice we've got 4 across the top and 4 across the bottom. So I've got 1 is going to be 3x plus 2y minus 7 equals 0. X plus 4y plus 1 equals 0. If I want my x terms to be opposites, what can I multiply one of these equations by? If I'm looking to make my x terms opposites, what do I need to multiply my second equation by?
Negative 3.
I'm going to multiply this one by negative 3. Let's look at number 2. Number 2, I have 3x plus 5y minus 18 equals 0. And I have x plus 2y minus 9 equals 0. What can I multiply my second equation by to make opposites of 3x? Again, I can multiply by negative 3. Let's look at number 3. Number 3, I have 4x minus 3y plus 1 equals 0. And 3x plus y minus 9 equals 0. Let's look at this one. This is the third one, top row, page 122. If you want to go ahead and number your problems across the top, 1, 2, 3, 4. The next one's on the second row, 5, 6, 7, 8. On number 3, I have as my x terms 4x and 3x. I don't want to have to multiply two equations. I don't have to multiply both of them. So now I'm going to focus in on my y values. What could I multiply my second equation by to make it the opposite of negative 3y?
3.
I can multiply by a positive 3. So if I multiply my second equation by 3, notice this becomes a positive 3y. Then I've got opposite terms here in the middle. So for number 3, you need to multiply your second equation by 3. And then let's look at number 4. I have 2x plus 3y minus 8 equals 0. And I have 5x minus 6y plus 7 equals 0. I look at my x terms. I have 2x and 5x. There's nothing I can multiply by one to equal the other or to make the opposite of the other. But if I look at my y terms, I have a positive 3y and a negative 6y. So what can I multiply my first equation by to make opposites with 6y, with negative 6y? If I multiply my first equation by 2, I'm going to end up with a positive 6y. Then I can cancel that with negative 6y. Okay, let's look at number 5. Number 5, I'm starting with 5x plus 3y plus 3 equals 0, and 2x plus y plus 2 equals 0. I want to make opposites. The easiest, if I do 5x and 2x, I'm going to have to multiply both equations. So I want to focus on my y's. What can I do to make my second equation opposite of 3x? Multiply by negative 3. Number 6, I have 4x minus 3y plus 12 equals 0, and x minus 2y minus 7 equals 0. Now I can focus in on these first 4x and x. I want to make the opposite of 4x, so I'm going to multiply everything by a negative 4. Number 7, 2x minus y equals, 2x minus y minus 3 equals 0. And negative x plus 3y minus 16 equals 0. So here you've got your choice. You could either focus on what to multiply to get your x's as opposites, or you can multiply to get your y's as opposites. Either way, you're still going to get the right answer. I typically just like to go ahead and work on those first ones. I just like to go ahead, since it's at the beginning of the problem, that's where I start. So to make 2x and negative x opposites, I just want to multiply my second equation by 2. I could multiply my first equation by 3 if I'd rather do that. It's up to you. And then let's look at number 8. I have 2x plus 5y minus 6 equals 0, and 3x plus 4y plus 5 equals 0. So again, I'm going to multiply, but here I can't multiply just one equation. I have to multiply both. So I'm going to start with my first ones. Now, if I wanted to do these in the middle, I could. I could multiply my first equation by 4 and my second by negative 5, or the first one by negative 4 and the second by 5. I could make those opposites if I wanted to. But again, I just like to start at the beginning. I just like to do everything the exact same way so I don't mess up and mix it up. So in the first one, I can multiply this one by 3 and I can multiply this one by -2. It's up to you. Or you could multiply the first one by -3 and the second one by 2. It doesn't matter which one you make positive, which one you make negative. The main thing that does matter is you're trying to make one term the opposite of the other so you can cancel them by adding. Okay? So that is your homework, is going to be page 122, activities 2 on notebook paper. Okay, page 122, activities 2 on paper will be your homework, solving by multiplying. Now, next week, we don't have class on Monday, so I won't see you two guys until next Thursday. I won't see y'all for a week. If you have questions between now and then, please let me know, okay? Be sure to let me know. We can set up a Zoom. We can figure out a time to meet next week at the co-op before class if we need to. Like on Wednesday, I'll be there for a while. Or we can set up a Zoom for next week. Whatever you need, please, 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 please just be sure to let me know if you're having trouble, okay? But if you're doing okay, your homework is page 122, activities 2 on notebook paper, and I will see you guys in class with all of the work we've done for the past 2 weeks. Everything is due in class on Thursday, okay? Bring your notes, bring all of your work that we have done for the last 2 weeks. Everything will be turned in on Thursday. I will send you a list of everything that needs to be turned in, okay? So I will send y'all a list. Hopefully I'll remember to do it today after I finish teaching, but I'm not real sure because I've got a couple of Zooms set up for after class today. But I will send out a list sometime between now and probably Monday. I will send you a list of everything that is due on Thursday, okay? But if you have questions, let me know. If not, I will see y'all next Thursday. Okay, bye-bye.
Bye.
Thank you.
Bye, everybody.
Bye, thank you.
Miss Jennifer, I had a quick question.
Sure.
So I didn't get my packet printed out until this morning because
Okay.
it wouldn't print out for some reason.
Okay.
I had to convert it to a different file and send it to my other computer to print it
Oh,
out.
goodness.
So I'm gonna try and fill it out before the Zoom.
Okay.
But I've already got some of the work done in there. And I think I'm starting to understand a little bit better what we're working on.
Good. Very good. I'm glad to hear it. So we've got our Zoom at 4. Are you still good for that?
Yes, ma'am.
Okay, so what we'll do is we'll go back through the packet and make sure we get it all filled out and make sure you've got everything, and we'll get it all caught up at 4.
Okay, I have some of the work from last Thursday done. I have
Uh-huh.
everything from Monday done, and I just need to
Perfect.
catch up on the rest of the work.
Sure. Well, we will
Okay.
get that done, okay?
Thank you.
All right. Thanks,
All right.
buddy. We'll see you in a little while.
All right, bye.
All right. Bye-bye.